picture, make sure that you get either a screenshot of this or you come into my classroom and you get a picture when it's up on the wall. Because all of the information that's here is also a logical flow. In that if you have a quadrilateral, then you have potential to be any one of these four-sided shapes. If you start all the way down at the bottom of this tree, then any of the properties that this shape has allow it to also be classified as any one of these on up the tree itself. Page 225, lesson 2, activity 3, is allowing us to make these logical statements about, is it a this, then it's a that sort of a thing. So let's dive into it. Let's take a look. For 5a, page 225, a square is also a rectangle. Let's determine whether each statement is true or false. And if it's false, we're going to draw a picture. Draw a counter example. Let's go. So a square is also a rectangle. Well, if it's a square, and this picture here, if it's a square, then that means that it's any one of the things up above it. So a square is also a rectangle is a true statement. The diagonals of a trapezoid are congruent. That's a false. I guess I'm moving across to the side. I know A, then letter D, then we'll go down the page. So the diagonals of a trapezoid are congruent. That works for isosceles trapezoids. True if isosceles. But that means we can also draw a trapezoid that's not isosceles. They happen more often than isosceles trapezoids. So draw maybe like a right angle, draw a line coming out. There you go. That's, clean it up. That's a trapezoid. Its diagonals, not congruent. So actually false. All right, part B. A rectangle is also a square. Okay, cool. So if a rectangle is a square, then that means that a rectangle has four sides. Two of them are the same like measurement, and two others are the same measurement. In a square, that's true, except all four of the sides are the same measurement, while in a rectangle, two of the sides are the same. So actually, to this statement, a rectangle is also a square. False. Here's a square. Boom, 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 boom. But here's a rectangle. Two of the sides have to be different from the other two. Okay, let's keep going. A kite is also a parallelogram. So a kite has two sides that are the same length. They're adjacent or next to or touching. And then you have two other sides that are the same length also, but they don't match in the same way. So because they don't match in the same way, that means that a kite is not a special type of parallelogram. Not. All right, kite versus parallelogram. A parallelogram is also a trapezoid. You know, for a parallelogram to be a trapezoid means that you have at least, maybe just one pair of parallel sides. In a parallelogram, the word is in the name, that two sides are parallel, and there's a second pair of parallel sides. In a trapezoid, there's one pair, at most one pair, at least one pair. A trapezoid is not a special type of parallelogram. A parallelogram is also a trapezoid. Not really. Okay, the diagonals of a rhombus bisect each other. That is 100% true. How do I know that's true? One, go back to that page like 220, I think, where we talked about it, as well as in a rhombus, you draw the diagonals because all of the sides are the same length. That means that opposite angles are congruent and opposite angles are congruent. So therefore, a 90-degree angle is formed here and here and here and here. Therefore, diagonals are perpendicular. Are also perpendicular and also bisect. Sorry, that's because it's a parallelogram. Let's go to the last part of activity 3. I want to finish this one out. Knowing certain properties of each quadrilateral makes it possible to construct the quadrilateral given only a single diagonal. So how would you construct a quadrilateral with the given diagonal? All right, I need a protractor for this one. Finding my material resources. It says given a diagonal WY. We have a parallelogram. Two sides are parallel. So I don't know how long those two sides should be. But if I draw my diagonal, from W to Y and label it W, Y, then I can form my parallelogram given like some amount of distance. This is a little bit weird. Describe how you construct each quadrilateral with a given diagonal. So I constructed parallel lines. I constructed a diagonal. You know, I'm going to have to read up on this one and get back to you. Let's go ahead and end it here. I'll have page 226's video for you next. Thanks. Bye.